This is Twit.
Bandwidth for Know-How is brought to you by CashFly.
This episode of Know-How is brought to you by Joby. Joby's GorillaPod is the signature flexible tripod amongst leading photographers and journalists. Currently, Joby is transitioning to a new production center and isn't accepting orders. However, leave your email with them for an update on product availability, and when they're back, receive 15% off your first order. Go to joby.com and enter TWIT at checkout. And by iFixit, the free online repair manual for everything. Before you start your next build or fix, head over to ifixit.com/twit to snag the fully loaded ProTech Toolkit for only $59.95 and check out their array of high-quality parts, tools, and guides. Today on a Halloween edition of Know-How,
a mad scientist bubbler.
It's a Twitch show where we build, bend, break, and upgrade. I am Father Robert Balacer.
And I'm Jason Howell, working up a sweat.
Yeah, that's right. We get pumped up with our little theme song there, but we got to get pumped up, Jason, because this is the start of our Halloween coverage.
I'm excited. Halloween is the time of year that I make the same joke I make every year. And call it Halloween instead. Because I'd like to turn everything into something about me, apparently.
That's such a dad joke.
I'm sorry.
We're so
but you know what? In my defense, I've been doing this for far longer than I've been a dad.
That's true.
So I guess it just comes naturally.
You know, I heard something in the car on the way up here today. That's Americans spend something like $7.2 billion on Halloween every year. Wow. That kind of blows the mind. And it is one of these things where people they cut loose. They do weird things. They buy a lot of costumes, a lot of candy, spend a lot of money on parties. So we thought we should probably do that. Now, we did some Halloween episodes last year, Jason, but the problem was we did them like the week before Halloween. No one has
time.
Yeah, you got to order the parts, you got to put it together. And we also wanted to do something that was simple. Some people have been complaining that some of our projects have gotten a little complicated. So we wanted to do something that was not that expensive, that looked good as a Halloween decoration, and maybe kind of stretch your maker limits just a tiny bit.
Halloween every year makes me feel guilty that I don't do more for Halloween.
Yeah.
Because I look at everybody else, like Padre actually, really goes and takes it to the limit.
A cyber priest.
I realize, yes. Wow, I love your costume,
I know, right?
Padre.
Every year.
You're very convincing.
It's damn good.
I know, you've nailed it at this point. But yes, I feel very guilty because I don't quite go to the lengths that a lot of people do. And this is no exception. I mean, I love what I'm looking at here.
Yeah. Now, this was a request. We have Carsten Bonney is one of our producers, and he's creating a haunted house for his kids and their school. Yeah. So he's like, well, could you do something like, we want to do the mad scientist thing? I'm like, yes, I can. And this is about as simple as we can get. It's basically a mad scientist bubbler. A little bit of 3D printed parts, a single Arduino, a ring of WS2812s, and an air pump to generate the little bubbles that will refract the light. Now, this is code that we've used on so many projects, so it shouldn't really be a surprise to any of the Arquitas. It's simple, and yet, if you put 4 or 5 of these next to each other, it looks very cool.
Yeah, set them off in the background, but I mean, the fact that they're all lit up from the bottom, and I mean, that's going to punch in the background. That's going to add a lot of dynamic and depth.
Oh yeah, now we're in a really well lit studio, and so you can kind of see it. But I mean, imagine a haunted house. It's at night. You know, you've got everything else kind of done up with the cobwebs and the fog, and then you've got the mad scientist part of the haunted house, and you've got a bunch of these, and then maybe some extra other stuff that we might be showing off in future episodes.
Maybe if you've got a nice sound system, you just get the sound of like bubbles popping.
Yeah. And little Tesla coils.
Yes. Just set it off.
So folks, the sky's the limit, but of course we got to start with this one. Now, let's start with a little overview of some of the parts that you're going to need, because you're going to have to order them now. If you want to make this for Halloween, this is the start of October. This is going to take about 2 weeks to get the parts, and then you've got another week to assemble everything, which should be perfect. You are going to need this. This is a WS2812 ring. If you go to the overhead, Burke, these are actually relatively inexpensive, about $5 a pop, and that's what they look like in the package. It's just 24 WS2812s, and Jason, I know you haven't been with our other WS2812 projects, but these are individually controllable LEDs, so I can control the color and the brightness on each and every single one with just a little bit of code.
That is really cool.
Yeah, it's $5, and you know, you can order these from Banggood, which is my favorite. I love them as a supplier, and it will fit perfectly. I'll show you how perfectly it fits into the housing that we've created for this. You're also going to need a power supply. Now, some people will try to run it off of the power of the Arduino. Don't do that. You can run about 6 or 7, maybe even 8 LEDs off an Arduino. You try to run 24, eventually you will kill the Arduino. That's just, it draws too much.
Oh, okay.
Because it's about 60 milliamps per LED. So for a ring like this, yeah, don't try to pull it off the internals. So I use this. You've seen these before. This is a UBEC. These are used for remote control models. It will take any voltage between, 6 volts and 24 volts, and it will convert it down into 5 volts, which is exactly what we need. This is a 5-volt ring of LEDs, and the Arduino is running at 5 volts. So if you go to that second link, there we go. It's about $3. It's fantastic because it is so forgiving. You can give it such a wide range of voltages, and it will convert it down to exactly what you need for the project.
What does it do with all the rest of them?
It's actually good question, because some people
just waste them?
No.
It sleeps on a bed of them?
Yeah, you know, it's just like, oh, look at all these volts.
I've got so many volts.
Electrons.
You've got none.
Yeah, actually, that's a very good question. Thank you for asking.
Yeah.
The old way we used to do it with like linear regulators is you would turn it into heat. Like any of the voltage you weren't using, it would just become heat, which is so wasteful. This doesn't do that. This is what's called a switching regulator. So it turns on a switch using transistors a lot of times every second. So you're only letting through the voltage that you need. So it's lower voltage, but increased current, increased amperage. Oh, okay. And it doesn't get hot. I mean, a tiny bit hot because you still have to power the transistors.
Right.
But you're not dumping all that extra energy into heat. Right.
Nice.
Now we need something to control it, because we've got the lights, we've got the power, now we need the brains. This is what I'm going to use. You've seen this before. This is an Arduino Nano. Now the link I have there, Burke, is again from Banggood, because I wanted you to be able to order all these parts from one place. Inexpensive if you order it in a group. This, you know, right now that looks like it's, you know, what, $6. But if you order it in groups of 3, 5, or 10, you can get them down to like $2 each.
Dang.
And I use these all the time. So if you're a maker, buy yourself a box of them, because you're not going to waste them. You're going to use them eventually, and the price is so much better.
Well, especially if you're going to be making a gaggle of these.
Exactly.
It comes in perfectly handy for this.
Yeah. The other thing that you're going to need is diodes, and I'm going to explain why we need diodes, but this is what they look like. This is my little power box. We want to be careful what we do with our power. These are 50-volt, 1-amp diodes. And actually, if you go to the link for this, you're not going to buy just 2. We only need 2, but they come in a pack of 100, and they cost $2 for the 100. So go ahead and buy yourself a 100 pack. These are perfect for the Arduino. Essentially, what we're going to need, and I'll explain this again later on, is we need the power to go from the UBEC to the Arduino. We do not want the Arduino to try to power the UBEC.
Yeah. Okay, explain that for me.
So these,
my brain's exploding a little.
Diodes only allow voltage to go in one direction.
Right.
So power can only go in one direction. So what we can do is we can set these up inside the leads, going from the UBEC to the Arduino, so that the UBEC will power the Arduino. So power can flow to the Arduino, but power cannot flow back.
Oh, okay.
Because the problem is when I plug a USB cable into the Arduino to try to program it, that gives power to the Arduino. If I don't have those diodes in place, what will happen is the Arduino will then try to power the LEDs and the UBEC, and it will kill it. Yeah, we don't want that. That's a bad thing. No. We also need an air pump, and I don't have to show this because it's under the table right now. But Burke, if you go ahead and go to that picture of that link, it's about $10. You might have an air pump. If you're going to do multiples of this, what I would suggest is you get one of the multi-outlet air pumps that have like 4 or even 5 outlets. It would be less than $10 each. So a single outlet will cost you $10, but I can get like a 4-outlet one for $20.
Oh, okay.
So if you're going to make a bunch of these, get the 4, and the price drops even further.
And connect them all in. And it's actually really small,
super
piece
small
of hardware. I think the picture made it look like it was a lot larger than it actually was.
I mean, okay,
so you can hide that really
easily. That's the
tiny.
pump. And the one for 4 is like that big. It's that much bigger.
Okay.
And yeah, you can put it under the, and actually I mean, that could be a cool soundtrack for for a haunted house.
Yep, absolutely.
It's one of those things like, what's that sound? What is it?
It's the sound of Halloween.
Okay, now there are some other parts that you probably already have around the house. The first is, if you go to the overhead, this.
Oh, yeah.
Just a 12 volt, actually anything, again, from a 6 volt all the way up to a 24 volt power supply, DC. Most of them have a 5.5 inch plug, and that's what we've set our project up to. So anything that does a 5.5 inch plug, a 5.5 millimeter plug, and between 6 and 24 volts will work with this project. That's why I didn't put it in the price list. You don't really need it.
And this thing that you showed off earlier is regulating that power so that only the right amount goes
precisely.
through. That's where
smart.
that comes in handy.
That's where the smarts are. Yeah, exactly. Yeah. If I had used like a linear regulator, then if I accidentally plugged like a 14 volt power supply, I'm now overvolting. Or if I plug in a 6 volt power supply, now I'm undervolting. That regulator is smart enough to just give me 5 volts. No matter what voltage I give it, as long as it's within its limits, it will give me 5 volts.
Nice.
Something else you probably have are M3 screws. At least I have these all over the place. They're pretty much in everything these days. If you don't have them, then you can go and go to this next link, Burke, again, from Banggood. It's just a box of M3 screws. It'll cost you like $9 to get it here. Again, one of these things where I always have a couple of packs of these because they come in useful, but everyone's got a box of screws. You've probably got a box of screws.
Yeah, up here.
And it will work just fine for this project. You're also going to need wire. I didn't put any links for this because you can get it on eBay. 24 gauge and 30 gauge silicone wire. You can use anything you want. That's what I use because I have a lot of it and because I like working with silicone. It's flexible and it bends well and it solders well. Okay.
Now, obviously, I'm seeing the base here, which is a big part of this.
Yep.
Obviously, it's what holds it up. Are they expected to have a 3D printer? Do a lot of?
No. Well,
how can they get that if they don't have a 3D printer?
If you don't have a 3D printer, what I would suggest, there's a couple things. You could go to Shapeways, which is this online place where you can send the files and they will send you the completed
I've heard of
parts.
Yeah.
They're a little costly. Their stuff looks great, but it's a little bit costly. The better option, and I say better because it makes you get involved with your local maker community. Almost every major city has a maker community, and there'll be someone who is willing to let you use their printer, or there'll be a center that for a very small, basically an entry fee, will let you come in and use anything you want. Find one of those because that's how you learn. It's not just the equipment, it's the people. The people will say, hey, you know what? I think that needs to change. And actually, Burke, if you go to my computer, we've done something different. I'm not just giving people the files. What I'm doing is I'm giving them the ability to actually edit the file. So I've given people access to all of the files that I've created. So this is the ring. This is the thing that actually holds the LEDs. Let's see if I got the other ones. I've also got the base, which is where we're going to put all the electronics, as well as what I call the cap, which is where the little bubbler is going to go down through. So because I've given you access to all these files, it means that once you've signed up for a Tinkercad account, you can change this to fit what you want.
Yeah, that's cool.
Right. So it's not just static files. I've given you the access to change this any way you want. So if you want to make it for a bigger container, you can do that. If you want to make it look a little bit more menacing, you can do that. If you want to give it a more rounded shape, you can do that. This is the idea. I give you the template so that everything fits, and then you can put anything around it that you like.
Nice.
Yeah, I like that.
Right on.
Now, there is one other thing that you're going to need. Container.
Yeah, I can't help but notice there's this other big, really very interestingly shaped, not quite so, it feels like I've never seen a container quite like this.
Yeah, it's
How
unique.
common are they?
Actually, super common.
Oh, okay.
Crazy common. I went through a couple of different choices, but I found that a lot of the containers that you could buy, they were too short, so you didn't get the full effect.
Yeah.
Or they were too wide, so it just looked like a bunch of water with bubbles in it.
Right.
I wanted something where it was tall enough so you could get the bubbling effect, and short enough so that there's no water here that doesn't have bubbles going up through it. If it was this wide, what would happen is you'd have a column of bubbles going straight up and down, and then undisturbed
a whole
water.
bunch of just regular water.
That's no good. And in fact, even the Aquavase project that we did a few months back, it was just this wide, and you could clearly see that. It's like there's water that never gets disturbed by the bubbles.
Right.
So what I did was I went downstairs from my room, and I went to the chapel. This is actually a very common cylinder. This is what votive candles for churches and temples come in. And folks, they throw these away. We don't reuse them. So if you live near a temple or a church, they will be more than happy to give you the ones that they're tossing out.
Oh, that's so cool.
Yeah, and actually you can tell, all that debris, that's what remains of the candle after it's burnt down. It's kind of disgusting. Yeah, it's you don't want that.
So I mean, you got to clean this sucker out before you're going to use it. That's probably not an easy challenge.
Not super easy, but not as hard as you might think. We're actually going to go through that in the second segment. I'm going to show you how to clean these out and how to prep the pieces. One last bit about this is that's the cap and extension. I actually divided this into multiple pieces for one reason, which is most people do not have a 3D printer that has that much height. So this is actually 2 pieces.
Oh, there you go.
And this is what you get a lot. So this is designed to go in here. And then what I do is I use my heat gun that I use for heat shrink, and I just kind of just keep turning it and melt it a little bit, just enough so that they get bonded. So the one that's in here, that's actually bonded together because I remelted the plastic and reflowed it.
Okay.
Yeah, cool, right?
Hey, you know what? You're smart.
Yeah, well, I've been doing this a lot. I mean, think about it. I have a job where people pay me to tinker with stuff I'd be tinkering with anyway.
It's pretty awesome.
It's kind of, every once in a while, you got to stop yourself and go, I get paid for this?
Yeah, I know. Cool. I know. I hear you.
Sweet. So we're going to get to that in just a bit. I'm going to show you how to prep the container.
Awesome.
I'm going to show you how to prep all of the 3D parts. And then I'm also going to show you how to put the electronics together because that's kind of important, right?
Yes.
But before we get to that, you know what I want to do?
I don't know.
I want to pay some bills, Jason.
Okay, let's do it.
Specifically, I want to pay some bills by thanking a sponsor of Know How who I'm so happy to have on board because this episode of Know How is brought to you by Joby. Now, you know Joby because way back when, they revolutionized the photography business by giving us a tripod that was unlike anything else we've seen. Now, we've had sticks, the traditional sticks that weigh a lot. We've had very short tripods that only work if you put them on tables. But what Joby gave us was the GorillaPod. It was this wonderful invention that let you wrap the legs around a leg or a fence post or basically anything. Give you the ability to get exactly the angle you want, exactly the shot that you want. Now, their new designs feature their signature ball and socket joint legs, rubberized grip rings, and stainless steel reinforced ball heads with a 90-degree tilt, perfect for shooting in landscape or portrait mode. Their GorillaPod flexible legs wrap around objects for unlimited angles and precise composition control, which if you're a photographer, you're gonna really appreciate. Now, those rubberized rings and foot grips provide stability on uneven surfaces for crisp, clear photos. If you've ever tried to use a traditional tripod and you just can't get it to balance out quite right, that's not a problem with Joby because you can individually articulate each one of those joints to give you exactly the level, exactly the angle, exactly the pitch that you need for the perfect shot. You can mount a variety of devices, including point and shoot, action 360 mirrorless, and DSLR cameras. You can also mount flashes, video lights, or any device with a 1/4 inch to 20 standard tripod mount. Now, I use a couple of these in my kit because I might want one for my camera. Maybe I want one to hold a mic. Maybe I want a couple to hold lights that I'm going to put up in the corners. It is a great addition to any photographer kit because it gives you flexibility in how you set up your shot, and it does it quickly, which is amazing. It's flexible, it's stable, it's versatile, and it's something that you need right now. So here's what we want you to do. We want you to grip it. We want you to wrap it. We want you to stand it. We want you to see the full line at Joby.com. Currently, Joby is transitioning to a new production center, and they're not accepting online orders. You can check back soon, or you can leave your email with them for an update on product availability. And once they are accepting online orders, enter TWIT at checkout to receive 15% off. That's Joby.com, and as soon as you can, enter TWIT at checkout for 15% off your order. And we thank Joby for their support of Know How. All right, Jason, I'm kind of sweating here.
Yeah, I know. We did work out right before this.
Well, actually, it's because I have a hot plate right underneath me. Yeah, it's putting a little bit of heat. Yeah,
all right.
Because we've got this, This probably won't look too good as a mad science bubbler.
Although when you look at this, the case kind of covers up some of that bottom part, but it's, the water's probably going to get all murky.
Yeah, you don't want that. And some people, because when I was first doing this project, I was searching online, and some people were saying, oh, well, if you put like acetone or petroleum mix, but I'm like, I don't want to create a witch's brew.
Right.
I want to clean this without using a lot of solvents, without a lot of chemicals.
Yeah.
And believe it or not, the answer was super simple, and it didn't require any caustic chemicals. All I had to do was heat it up. So this is one that I've been working on for a bit. As you can see, all the wax and the debris has risen to the top. And the way that it's risen to the top is that I'm using one of these. This is just a simple burner, a little electric heater. Yeah, so it allows me to do this, and I just keep this just slowly heated up until all the wax has risen to the top, and then I'll just dump it into a receptacle. Now, the wax, you probably don't want that coagulating on your pipe, so I would dump it outside.
Yeah,
but
absolutely.
There's nothing toxic, there's nothing caustic, this won't kill anything. And the nice thing about it is all that debris, that's not like a nasty chemical, that's just burnt wick. That's all that is, like match heads, basically.
So you're heating up the water, and by doing that, that heats up the wax, lets it release from the glass and floats up to the top. Now I can see a little bit of this kind of sticking around the edges, which might be hard to see right there. I mean, do you just then go in and scrape that off? Or
yeah, so what I'll do is I actually take, this is like when we were kids and you wanted to clean out the inside of a bottle. Basically take a bunch of paper towels.
All right.
And you just, once the wax is heated, so it's got to be hot.
Right.
Pour out most of it, and then just make a wad of paper towels and just put it in there and start turning.
Okay.
And you get this. I mean, this was literally after, this one on the table, after about 5 minutes of cleaning. And it's such an easy thing to do. I don't know why you wouldn't. Yeah, see?
Okay. Yeah. No, I mean, you wouldn't even know.
Yeah. And again, you don't need any chemicals. You don't need to really scrub it out. In fact, I just let this thing sit. Sometimes it takes a little longer depending on what kind of wax they actually used in the candle, but wax is lighter than water, and those wicks are all lighter than water, so eventually they will release, and once they release, they go to the top. So everything below this ring is clean.
Wow, not bad.
Yeah. And,
better than getting in there and trying to scrape the bottom, which is probably what I would have done if I had been presented with this challenge.
Well, yeah.
I guarantee you I would have given up because it would not work.
Someone suggested, they said, well, what you need to do is you need to burn off all the wax. So if you put some lighter fluid in there, I'm like, I'm not setting off a glass bomb, man.
Yeah, no.
Dude,
no,
what is wrong with you?
No, thank you.
So again, that's just get yourself a heater. I will say this, if you're going to be doing this as a project, do not, please do not use an open flame, because you actually can crack the glass.
Yeah, the glass will shatter.
You can heat it so fast. Get yourself one of these. You can find them on Amazon for about $10 if you don't already have one. Just a hot plate. You can more closely control the temperature.
And how hot are we talking about, like when you're melting this? Because you don't want to go too hot with glass that's not
even when it's hot enough to melt the wax. Yeah. I can still hold this.
Okay.
So the wax is melting right now.
All right.
Yeah, and actually, if it's too hot, then just turn it down. Yeah. Because this is something that you can just, if you're in a workshop, just leave it on the workshop and just keep checking over every once in a while to see if all the wax is lifted.
Yep.
And once it's lifted, it's good for you to go ahead and dump outside and then get the rest of it.
Candle wax is a lower melting point than regular.
Exactly. Yeah. Burke said that candle wax is not like paraffin wax. It actually melts at a much lower temperature. And votive candle wax has a really low
votives burn pretty easily. Yeah, or melt pretty easily.
Yeah, because that's what they're designed to do. Yep. This whole unit is the candle, and you put it in, and this thing will burn through in like a day and a half. And so you don't need it to burn forever. It just has to burn long enough for the devotion to be over.
Right.
Yeah. Okay, so let's go from that. We got our glass now, and by the way, this is also why I gave you the actual links so you can work on the files. If you don't have a church or a temple, or if you're too shy to ask them, you can go ahead and buy yourself any containers, and then you can just resize the files that I gave you. So just alter those to fit the container that you have. But I love reusing stuff, and these containers get thrown out. I mean, the 4 that I have, I got them, on Tuesday, because they were just sitting in the back of the chapel. Like, oh, okay, these are mine now.
Yeah.
Yeah, so basically,
I'm just in my head. I'm trying to think of what other like cost-effective way there would be to do this. And I'm like, okay, well maybe water bottles, but no, water bottles are expensive.
I've done that.
How else do you get this tall kind of glass? Like this seems like perfect for the project.
One that's closest. You know the smart water bottles, the plastic ones.
Oh yeah.
If you remove the labels, those kind of work. But the thing is, it's plastic.
Yeah.
And it doesn't look anything as good as glass.
Yeah.
Because you get a little scratch in the plastic, and now it looks like a plastic bottle.
Yep.
Glass will always look kind of cool.
Yep.
Yeah, all right. So let's talk a little bit about the 3D part. So we already talked about the this. You can hold on to that. That's the little cap.
Ah.
Oh, or you could drop it.
There we go.
Just 3 parts. So the cap, and then I've got the LED holder. And if you look at this, that little trench on the side, that's where the LED ring is going to fit. So actually, I can take this, and I'll put it down like this. And the whole idea is, the reason why I have that raised ridge is because the raised ridge is going to support the weight of the glass. The LEDs don't have to support any of that weight. You don't want that weight on the LEDs because you'll break the LEDs.
Yep.
And it just goes right down like that, and it's a perfect fit. If you buy the ones that I have linked up, they fit exactly into that trench. You might have to remove any like little bits and pieces that are hanging off the edges.
Can I see that for a second? So you've got the LEDs kind of fit in there.
In that trench, yeah, the light trench.
In the trench. And then the base of the glass, how is that missing?
It just goes straight in. It's designed for that size.
Wow, nice.
Yeah. Now, the cool thing about this is, the reason why I designed it with this double-decker construction is because I wanted you to be able to make this and then install all the electronics and just put this on top. There's actually 4 mounting screws inside of here so that I can take this and do that. There you go. And now I've got a complete unit. So I put the 4 screws, and now it's 1 unit.
That's great.
But if I need to fix anything, I don't have to tear it apart. I just unscrew those 4 screws, pull this off, and now I've got access to all the electronics.
That's very smart.
Yeah. So, and this is where the 3D design comes into play, because you start to notice, so like, oh, I can make it this way, but then if I ever have to fix anything, I basically have to destroy it to get at the electronics.
Yep.
No, don't do that.
Probably don't want
that now. But here's the thing. Anytime you've got a 3D print where you've got like this hole, so this is where the little 5.5 millimeter jack goes for the power, it has to print supports, because what's happening is you're making this curve, but there's nothing to support the material on the top. Do you see that?
Okay.
And so if you left that empty, what would happen is that would just kind of sag in and it would destroy the print. Yeah, if you go to the overhead, Burke, that right there. So the first thing we need to do.
If that was an empty hole, that would kind of throw off the integrity.
It would sag in, right? Now that actually might not be too bad, because there's a curve, so you might be able to keep it. But on this side, that's where the Arduino goes, and that's a 90-degree angle. Absolutely, that would just collapse on itself.
Got it.
Now what we're going to use, I'm going to use a couple of iFixit tools, because this is what I use. I love them. I use this thing. I don't know what the name of this tool is, but I call it the pokey stick of death.
The jabber thing.
The jabber, yeah, the jabber thing. And what you want to do is you want to just, this plastic, so this filament is actually, it's much more hollow. So it's not as solid as the rest of this. So you can just do that. Just kind of poke it with a jabby poker walkie stick. And then once you've made enough holes, switch this over to the flatter side, and you can just kind of force all that out.
I mean, this is Halloween, so this is kind of fitting that you're stabbing at the base here.
I just need enough to be like that, and do the same thing for over here. So I'm going to go ahead and force, actually let's use the pokey stick of death side first. There we go.
Excellent.
Like and then use the other side and just top the rest of that out. Drag it out.
And I'm having flashbacks of a dental visit that went horribly wrong.
Is it safe? Jason, you do not take care of your teeth. Have you flossed? Okay. Now, this part is easy. This where the Arduino fits, that's going to fit quite well. This is kind of touchy, because what's going to happen is I need to put this jack, this 5.5 millimeter jack, into that hole. And if it's not cleared, it just
it's not going
to
go.
fit.
So you have to file that down?
File it down, and actually, yeah, you can actually just take a nail file and just just go back and forth. Or if you're like me and you got a bunch of tools and you like to make a lot of noise. Speaking of the dentist
Speaking of the dentist, my goodness, seriously.
So all we're gonna do is, I should be wearing glasses, but I'm not gonna. basically just go around. There you go. And what we're going to do is we're just going to keep enlarging it a little bit at a time.
Until it fits perfectly.
Until this thing fits, right. And you don't really need that much because a little bit of force, see it's getting much closer now, a little bit of force just brings the bit straight through the filament, like butter, Jason.
Yeah, it's going to work now. Yeah?
There you go.
Yeah.
Okay, so that's what you want.
Like a glove.
And the reason why I picked this is because there's a little bit of overhang, so even if you cut a little bit too much or you mar the surface, it will cover
still
that
gonna
up.
pop. Yeah, it's still going to have that lip.
Right.
Yep.
So once this is ready, you're prepped. You've got your glass clean. You've got your 3D parts ready. Hopefully you've bonded together your little cap so that this will work properly.
Right.
And now we need to work on the electronics. So without further ado, hey Burke, push the magic button. Assembling the electronics for the Mad Scientist Bubbler is actually pretty straightforward. You'll need a 24 LED WS2812 ring, an Arduino Nano to drive it, a 3 amp UBEC for the power supply, a 5.5mm power jack, and 2 diodes. The first thing we're going to do is to load the code on the Arduino. We do this up front because we want to make sure the Arduino is functioning properly before we solder it into the project. If your computer recognizes the Arduino and successfully uploads your code into memory, then you're ready to start assembling the electronics. Let's start with the LED ring. We need 3 wires to power and control the ring. 1 for ground, 1 for 5-volt power, and 1 for the digital control pin from the Arduino. Turn the ring over and you'll see 4 pads: DI, or digital in, 5V for 5-volt power, GND for ground, and DO for digital out. We're not daisy chaining this ring to more LEDs, so just tin the DI, 5V, and GNT pads with a small dollop of solder. Heat the pad, not the solder, and don't put too much. I'm using 24 gauge silicone wire for my power connections and 30 gauge for my data. It's flexible, resistant to heat, and easy to work with. In this project, I'm using red for 5-volt power, black for ground, and white for data. Cut about 7 inches of each color, then strip and tin the ends. Solder one end of each wire to the pads on the LED ring, making sure to orient the wire so that the slack runs into the middle of the ring. Again, white to DI, red to 5V, and black to GND. Once you're satisfied with your soldering job, let's insert the ring into the LED ring assembly. There's a notch cut out on one side of the bottom of the assembly. This is both the front of the assembly and the channel for the wires soldered to the bottom of the LED ring. Gently push the ring into place, making sure that the wires are in the notch and the LED ring is pushed all the way into the LED trench. There are 4 holes underneath the LED ring in case your alignment is off. Simply push a tool through the holes to pop up the ring and start again. With the LED ring and the LED ring assembly, we can set it aside to work on the base. The base houses the Arduino, the UBEC, and the 5.5mm jack, as well as the diodes. Strip and tin the input leads to the UBEC, then push them through the nut and washer in that order, then through the mounting hole for the 5.5mm power jack. Slip a piece of heat shrink tubing over each lead, then solder the red positive lead to the center pin and the black ground lead to the sleeve. Slide the heat shrink over the solder joints and heat them to insulate. Push the 5mm jack into its mounting hole, then slide over the washer and tighten the nut to secure the jack into place. The next part of the power system is a little bit tricky to assemble because we want the UBEC to power both the Arduino and the LED ring, but we don't want the Arduino to power the UBEC or the ring when we plug it into a USB port for programming. Doing so will draw far too much power from the Arduino's power supply, eventually leading to its destruction. This is why we need diodes. We're using a pair of diodes, one for the ground and one for the 5-volt line. Diodes only allow power to flow in one direction, from the anode or negative end to the cathode or positive end. By using them in line with the leads going from the UBEC to the Arduino, power is allowed to flow to the Arduino, but not back to the UBEC or LEDs. We're going to cut 4 short pieces of 30 gauge silicone wire, 2 red and 2 black. Strip and tin all ends, then cut the leads on the diodes to about 1/2 inch each. To one, solder black leads to each end, to the other, red leads. Insulate with heat shrink. Now we need to solder the power leads to the 5-volt and ground pads on the Arduino Nano. Look closely at the diodes. You'll see that one end has a band. This is the negative side. power will flow to this end from the other, but not the other way around. We want power to flow through the red leads to the 5-volt pin on the Arduino and out the ground pin. Line up your wires so that the band on the black wire is further away from the Arduino and the band on the red wire is closer to the Arduino. Then solder in place. Cut, strip, and tin the output lines from the UBEC. Now slip a piece of heat shrink tubing over the lead and connect all 3 red lines, one from the UBEC, one from the Arduino, and one from the LED ring, and solder them together. Do the same thing for all the black lines. Slide the heat shrink tubing into place, then apply heat to insulate. The last step for the integration of the electronics is to connect the data line to the Arduino. You could use any digital pin that you like, but the code that I created for this demo uses digital pin 3. Solder the wire to the appropriate pin and set it into the mounting channel in the base. Now, for the moment of truth. Plug in your 12-volt power supply. If you wired everything correctly, you should now be treated to a mad science light show. I'm happy that you're happy.
Yeah, well, hey, once those lights turn on, it's like all that effort.
That's what I like about these projects, which is, you know, it's when it works, and if it doesn't work, it doesn't work. So you know when you've done something awesome.
The problem is if you've soldered a bunch of things and then it doesn't work.
Yeah, and actually the first version of this that I made, I was doing it really, really late at night, and I actually reversed the diodes. After I just had written the script of make sure to check the diodes, I'm like, oh. So this was after I soldered everything together. I'm like, oh, clip, 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 clip. Let's do it again.
I guess you're not getting any sleep tonight.
Yeah, I'm getting old. So before we put this together, if you go to the overhead, Burke, so what we want to do is we want to make sure that everything is working. I've got my UBEC, so power is going to come in on this jack. Actually, it's go here. Power's going to come in on the jack, go to the UBEC, get from converted down to 5 volts. It goes to this little assembly right here. This assembly splits it off between powering the ring and powering the Arduino. And as I go through the Arduino, I hit the diodes, so power can only go to the Arduino. It's not going to come from the Arduino back out, right? I've got one single line from that data line, which is pin number 3, into this. That's what's going to give it the control. So the UBEC provides power, but the Arduino is actually sending the array to the individual LEDs to say light up green, light up blue, light up whatever it's going to be. We're not going to go over the code because I've gone over it several times, and we'll do it in another episode. But what we need to do now is test. Before we close this thing up, let's make sure that it's actually going to work. So I've got a 12-volt power supply. When I do this, there we go, I see lights. So I've got lights. Now it's loading the firmware, and boom.
Whoa!
Okay, if I see that, yeah, it means I'm good to go.
That's awesome.
There we go. So that's going to illuminate up through the glass. Now let's go ahead and assemble this. I've got these little 3M screws. This is going to go like this. And like I mentioned before, that channel is also the front. And the front I know is here because the back has the plug. And I have to line it up so that the mounting holes in these things line up with the mounting posts there.
Of course.
Right. And if they do, then it makes it really easy for me to do that. So that's my correct orientation because I can see the actual mounting holes. I'm going to do 2 for now just because, you know, I want brevity. But these are the reason why this is threaded. The reason why it's easy to go in is because I've already gone in with the screws just to make sure the thread exists. Yeah, I can't 3D print the threads.
Well, no, obviously. And the first time you go through, you're basically setting the threads into the plastic.
Yeah, and design thing, if you are going to be playing with it, the way that you do that is these are 3mm screws, and I make the channel 2.8 millimeters, and I make it octagonal. So you know, so it actually has to create the threads to get through it. That's the way to do it. Yeah.
Nice.
Okay, so I've got my 2 in here. Now let me show you the difference between project 1 and project 2. So this is just standard water. There's nothing else in here. It's just water. What I'm going to do is I'm going to go ahead.
Not vodka.
Not vodka.
Okay.
Let's go ahead and run this through here. So I take my channel. I've got my little air tubing. I'm going to run it through like so. Oh, and by the way, one of the other things you can do, although it adds expense and complexity, is I've actually encapsulated this in copper tubing so that you can do like a little...
Oh, yeah.
But I mean, it is kind of expensive, so that's why I left it out. The copper tubing is not cheap. So I'm going to go ahead and put this in. This is, by the way, this is an air stone. This is just so that the bubbles get diffused a bit better.
Yep, we have a fish tank at home.
Yeah, so you know
it has one of those as well.
So I'm going to do this. Now what I'm going to do is go ahead and give power to the Arduino so the Arduino can control my LEDs. And then I'm going to plug this into my air source like so. So that's what it looks like. I mean, this is not bad. And this is,
okay.
Again, because
like
I'm using the constrained glass, so I get a nice stream of bubbles. But this was okay. I thought I could do better using these. Now, we've seen these before. These are water beads. So this is like silica. And each of these little teeny tiny beads, I mean, they're like the size of a large grain of sand. They will expand into this. So each one of those little ones into one of these big marble-looking things.
Wow, they feel really weird.
They do feel weird. But the reason why I want to put that in there is the issue with this is the bubbles are going straight up. And I mean, I can see the light, but I would see it better if there was a bit more diffraction, if the bubbles were bouncing around a bit more, right?
Yep.
So this one over here, this jar, actually has the poly beads in it.
So looking in here,
you can't tell.
No, you can't tell. When you look in there,
wanted
you
that
can hardly
deliberately
see that there's anything in there other than water. But yeah, I can see it actually. Wow, that's fascinating.
What I'm going to do is now I put this down into this container. Oh, there we go. Take this one off. There we go. Now the cool thing is, see the bubbles, they're forced to go around the poly beads. And you get that weird, like the first time you look at it, you don't realize what's wrong until you realize the bubbles shouldn't be doing that. Like they should be going straight up, but they're going these little zigzags.
Yeah, they're finding their way around the bead. That's a really cool effect. I'm just blown away that you can't even see those beads in there, but you really can.
You can see the shape now.
Yeah, if you look really closely and like concentrate, you can kind of see the airs go around it.
I mean, it's almost, it's like you're looking at an invisible,
there's
invisible
a force field in there.
Exactly.
Let's go. Witchcraft.
That is awesome. That is really cool, Padre. I love it.
Now, folks, this was all made possible by the next sponsor of Know-How. Now, when I put together projects like this, in fact, you just saw me use what I'm calling the metal pokey stick of death to open up my.
I'm sure that's a technical
parts.
term.
It is. It's totally technical. It's pokey part and the blunt part. What I need is I need a little bit of iFixit in my life. Now, iFixit has been the purveyor of fine tools for so long. They've been sort of the patron saint for Know-How because they get me. They understand makers. They understand DIYers. They understand that when I'm putting together projects like this, I don't have time to worry about whether or not my tools will fit. Now, Jason, have you ever tried to use the wrong size screw head to get a screw out just because it's the only one you have?
Absolutely, it's a bad idea.
Yeah, it always turns out well, right?
No, it does not.
You end up,
don't misinform. No, it's a nightmare. Like I've stripped them, and that's the worst thing in the world. Then how do you come back from that?
Or trying to open up an enclosure, and you're just using like the flathead screwdriver. What's going to happen? Well, you're going to mark the heck out of it.
Yep.
You might be able to get in, you might be able to fix it, but now you've permanently damaged the device.
Yeah.
I used to do that all the time because I didn't think there was anything else I could do about it until I learned that there is, and that other thing is called iFixit. Now, this episode of Know-How is brought to you by iFixit. Now, if you're familiar with iFixit, you know that they really like to take stuff apart and teach people how to fix things. They're constantly posting teardowns and repair videos for popular devices like the Galaxy S8, the iPhones, and the Switch. They're also leading the charge in electronics repair tools with their iconic black and blue ProTech Toolkit. Now, if you check out the ProTech Toolkit in their store, they explain how each piece of the kit was meticulously designed. This is not just a hodgepodge of individual bits and tools. They actually reached out to the community and they said, what do you need? What is it that will help you do your job better? And that's what went into the kit. You won't find a higher quality toolkit like this on the market. Now, don't let the sleek design fool you. This toolkit's got both beauty and brawn, with high quality steel bits and tough tools enough to handle any repair or mod that you throw at them. And get this, it's only $59.95. The tool roll makes it compact and easy to store. The included 64-bit driver kit has all the bits you'll ever need for just about any DIY electronics repair. A protective case that keeps your bits organized. You just open it up and flip it over and the bits won't fall out because they're held in place by a magnetic mat that also doubles as a perfect spot to hold tiny components and screws. They give you a swivel top magnetic precision driver and a flex extension, also magnetic, for hard to reach screws, or when you drop those screws down into the case and you don't know how to get them back out. They've also got a wide variety of plastic opening tools, spudders, and picks to safely poke and pry with, as well as the suction cup, which is perfect for removing a screen from an iPhone or an iPad, an Android device, or even Leo Surface Studio Pro. They've also got the rubber-handed Jimmy pry tool and a set of metal spudders so you can get into the cases without destroying them, and ESD-safe tweezers and an ESD safety strap so that you don't accidentally destroy your job with a jolt of static shock. And the best part? iFixit's tools are backed by iFixit's lifetime warranty. You don't need to buy something to get iFixit's free repair resources, by the way. You can check out over 25,000 free repair guides over at iFixit.com. If you want a manufacturer, a tool supplier, a parts supplier that gets you, then you need to check out iFixit. If you want to tackle your next hack, fix, or build with the ProTech Toolkit, just visit ifixit.com/twit to snag the fully loaded ProTech Toolkit for only $59.95. We thank iFixit for their support of know-how. Now, Jason.
Yes.
Here's the fun part about making. As I was going along, I was thinking of all the other cool things I could add. I actually wanted, I wanted to enclose this in the side. I wanted to make it like a little add-on to this. And I also had, I had already built this sort of steampunkish type things with brass gears that would actually turn. I had a control panel on the side that would allow you to turn things like turn up the air or down the air, mess with the lights. But then I thought about, I'm like, wait a minute, who is this for? This is for a haunted house. The last thing you want is a bunch of kids poking at switches on a container filled with water made out of glass. And so I kind of scaled that back. But that design's ready when I want to build in the future.
Yeah, probably a good idea. Although depending on how you do the haunted house, like of the haunted houses that I've been in, there are certain things that are accessible to you as a person roaming through it and certain things that kind of blend into the background. This I could totally see, yeah, part of the foreground, but also in the background. It would be nice to add, you know, on some of them, a little bit of variability so you can kind of change the look and feel of it and all that kind of stuff.
And I was thinking, you know, I was like, oh, I should make this interchangeable. So I can just, like I could make a rack of 4 and they're controlled all by one. And that might come, but again, because of your feedback, you told me sometimes the projects get a little too crazy. This is about as simple as you get.
Yeah, this is super accessible.
Yeah. It's a ring of LEDs, it's a power support source, it's an Arduino, and it's an air pump.
Nice.
And you know, assuming that you either have a 3D printer or will use Shapeways or use a friend's 3D printer, and assuming that you live near a house of worship that's throwing away a bunch of votive candles, this whole project, even with a pump that you pay way too much for, is going to cost you like $20, $20-25 maybe.
And that'll actually decrease in total cost
the more you
if you're ramping it up. If you want 5 or 10 of these or whatever, you scale up that cost. A lot of the examples that you showed off, you get a discount on
Precisely,
a bigger purchase. So.
If you make 1, it's going to cost you $25. If you make 2, it's going to cost you $40.
Right.
You make 5, and it's going to cost you like $80. So I mean, again, it scales up. The more you want to make, the less it's going to cost. And it's always good to have those parts in stock because, well, we use them all the time.
Yeah, totally. And the way that you've made it also, because you pointed this out earlier, the way that you made the base separate, you know, the ability to kind of separate it means that you can take the Arduino out, use it on something else, and then, hey, Halloween rolls around once a year.
Exactly.
So throw it back in there, use it for this, and, you know, it's multi-purpose.
I actually built something like this for our aqua vase, and my sister saw it. And she goes, oh, that's really cool, can I have that? So I gave it to her, and I just recently visited her house. She's not using it as an aqua vase. She has like a couple of like marble crystal type things, and she built a small platform and just sits on it, like makes them glow and sparkle. I'm like, okay, well, light's a light.
Yeah, right.
If it works for you, awesome, good deal.
Exactly. That's super cool.
Yeah, we're going to continue with the Halloween stuff. We've actually got a project to create a super simple string of lights so that you could like get that eerie, glowing red effect. And also, I'm building a Cyberman costume.
No big deal.
Yeah, it's, NBD. Yeah, so you got that. You got to look forward to.
Cool.
So what are you going to do for this Halloween, Jason?
I was afraid of that question because this Halloween's a little different for me. I'm going to be, well, here. It's Tuesday.
Wait, what?
So I got all that Android. Normally I would be, you know, walking around the town with my family. We always do kind of like a family costume, you know, idea, usually picked by the girls. This year, I'm going to be here. I'm going to be a podcast host. for Halloween
How about
this year.
this? I mean, I know Carson wants to take a few of these, but I'm going to build some extras just so we can decorate the All About Android set with some mad science.
Yes.
Can we do that?
That would be awesome.
We'll do that.
That'll make me feel at least a little more festive. I should probably come up with something to wear to work.
I can give you a priest outfit.
Oh, that's a really good idea. I believe you when you say
Actually,
that.
there's this link to this costume. It says Cyberman or priest. It's like a cassock.
It's an inside out.
It has been sent to me at least 100 times, and I'm like, yeah, I might actually buy that now. That'd be perfect for you.
Perfect. All right, sign me up.
Folks, we know that this was a lot of information. We want to make it easy for you to build this project. I actually give you step-by-step instructions at our show notes, which you're going to be able to find at twit.tv/KH for know-how. Now, while you're there, you're also going to find a little drop-down menu to subscribe. If you want to support the show, if you want to see more know-how, if you want to see more projects like this is the best way to do it. You can get an audio version, a video version, or a high-definition video version. You can share this link with your friends so that they can subscribe. Because the more people we get subscribing, the more people we get downloading know-how every week, the more projects like this we can bring to you. Also, don't forget that we're on the socials, specifically on Google+. Just go to Google+, look for know-how, ask to join. It's a very short approval process. I approve everyone, but it also just lets me keep out the spam accounts. Once you're in, you get access to almost 12,000 ketas. Those are our know-it-alls. People at every stage of their maker DIY journey. You can ask questions, answer questions, and post pictures and videos of your project so that we can show them off in know-how. Nothing makes us more proud than to see you take something that we've done and do something 100 times better. So please, again, go to Google+ and join know-how. Don't forget that you can also find us on the Twitter. Specifically, I'm at twitter.com/PadreSJ. Jason, where do they find you?
That's pretty easy. At Jason Howell, pretty easy to find.
Oh, and by the way, I understand that Twitter still hasn't verified you. You know.
Thank you for mentioning that, Padre. Yes, it's true.
Twitter.
It's okay. I'm just a podcast host, right?
Twitter.
I'm not a journalist.
Be nice, Twitter.
I'm just on the internet.
We might
I'm just on the internet, that's all.
We may have to do a know-how on know-how to get verified.
Oh, yeah, okay. Sign me up. I'm totally there.
We've also got a third member of our crew, and tonight, it's a very special man. You know him, you love him. He's probably broken something that you own. It's Burke. Burke, where do we find you? Okay. You can find Burke at twitter.com/ANELF3. And there we go.
Good work, Burke.
Good. Well done. Until next time, I am Father Robert Balacer.
And I'm Jason Howell.
And now that you know how,
go boo it. Huh? See what I did there? Huh? Okay, all right, good.